So to begin, we're going to be explaining how aluminum is made based on someone with a general chemistry background and using what you would learn in the classroom and applying it to a more real-life situation. To begin, there are two different routes you can take when creating aluminum. Primary aluminum production comes from ore, and recycling aluminum from process of scrap and used aluminum products is the other option. The production of primary aluminum consists of three different steps. There's bauxite mining, alumina production, and electrolysis. Aluminum ore, or most commonly referred to as bauxite, is plentiful and occurs all over the world, but more particularly tropical and subtropical areas. Bauxite is refined into aluminum oxide dihydrate, or alumina, and then electrolytically reduced into metallic aluminum. Primary aluminum production occurs all over the world, often in areas where there's lots of inexpensive energy like hydroelectric power or geothermal energy, which is why part of this presentation will focus on the Fjarðal plant in Reyðarfjörður, Iceland. To begin with our discussion, we'll skip over the discussion of how bauxite is mined and etc., and just jump right to the chemical processes of it all. This begins with the alumina, not aluminum, refining. The aluminum making process relies on a process called the Bayer process to produce alumina from bauxite. This process is one of the most economic means available of obtaining alumina, which in turn is vital for the production of aluminum metal. The primary aluminum industry depends on this alumina for four basic primary functions, first of which is the aluminum production itself. It also helps act as a thermal insulator for the top of the electrolytic cells, which will be explained later on, as well as coating for pre-baked anodes, which occurs later in the process, and finally it is an absorbent filter for cell emissions, which again will be explained further down the line. So how is this alumina used, bauxite, to produce aluminum? Well, first, bauxite is washed, then it's ground and dissolved in sodium hydroxide at a very high pressure and temperature. The result is a liquor substance containing a solution of sodium aluminate and undissolved bauxite residues, which have iron, silicon, and titanium. These residues of the iron, silicon, and titanium sink gradually to the bottom of the tank where the bauxite was washed and is removed as what is commonly referred to as red mud. Then this clear sodium aluminate solution is pumped into a huge tank called a precipitator. In this tank, fine particles of alumina are added to seed the precipitation of pure alumina particles as the liquor cools, thus resulting in a more solid powder-like substance. As the particles sink to the bottom of the tank, they are removed and then passed through basically like a dryer at an extremely high temperature to drive off the chemically combined water in there. The result is the fine white powder of pure alumina. To further explain the Bayer process, we can break it down into three stages. The first is extraction. The hydrated alumina is selectively removed from the other insoluble oxides, as discussed before, by transferring it into a solution of sodium hydroxide. And then, as you can see, the chemical equation is presented above. This process is much more efficient when the ore is reduced to very fine particle size prior to the reaction occurring. after the extraction stage of the liquid, which contains the Al2O3, must be separated from the insoluble bauxite residue and purified as much as possible, and then it is filtered into a decomposer. The mud, the red mud, is thickened and washed so that the sodium hydroxide can be removed and recycled. The next stage is the decomposition stage. Crystalline alumina trihydrate is extracted from the digestion liquid by hydrolysis. And here's the equation. This is basically the reverse of the extraction process that we just showed, except that in this process, this stage, the product's nature can be controlled by the plant where the alumina is being made, and it's the conditions at that plant. Some of these conditions include precipitation temperature and cooling rate. The alumina trihydrate crystals are then classified into size fractions and fed into a rotary or kiln to be heated and prepare them, the alumina, for the aluminum smelting process. Now, how does all of this tie in to getting from the powder form of alumina to the actual aluminum that we use every day as, say, aluminum foil? Well, the next step after you've produced the powdered alumina form is the aluminum smelting. So the basis for all of the modern primary aluminum smelting plants is a process called the Hall-Héroult, which was invented in 1886. This process involves dissolving the alumina in an electrolytic bath of molten cryolite or sodium aluminum fluoride. This occurs within a large carbon or graphite lined steel container, which is known as a pot. An electric current is then passed through the electrolyte at very low voltage but a very high current, which is about 150,000 amperes. The electric current flows between the carbon anode, which is positive, made of petroleum coke and pitch, and a cathode, which is negative, which is formed by the thick carbon or graphite lining of the pot. Molten aluminum is deposited at the bottom of the pot and is siphoned off periodically, taken to a holding furnace, which there it is blended to an alloy specification, cleaned, and then cast. So let's just take a break here, and you can see where some of the topics that we've been discussing in our general chemistry classes, such as the cathode and the anode, how does this apply to even bigger picture than just the batteries that we've discussed. It's used to make the everyday products of aluminum, that everything that we use has some sort of aluminum, or even just in the kitchen, aluminum foil. So it's just kind of putting things into a perspective of, you actually do and can use what you've learned in class. So we'll go more into depth with exactly how that happens, because that was kind of a quick overview. Kind of break it down a bit, and then go from where is this actually being used, how is it being used, and who does it affect. So we are going to begin this whole discussion of how aluminum is made and smelted by using a example that's kind of unique and a little bit more interesting than just overall in general how aluminum's made. Recently there was a plant built by Alcoa, which is an aluminum company, in Reyðarfjörður, Iceland. And the whole reason for building it there had to do with the access of cheap power, due to the hydroelectric power as well as the geothermal energy from the ground, which we're hearing about in the news today with all the volcanoes. So I thought I'd focus on this plant more as a current event topic so that people could relate.